And we're back, more or less. Hope your spring bake was good. I slept a lot. So the last thing we did when we left off was talking about the law of conservation of mass. And on your balancing act worksheet, balancing act, at the top it says atoms are not created or destroyed during a chemical reaction. This is called the law of conservation of mass. Scientists know that there must be the same or an equal number of atoms on each side of the equation. To balance the chemical equation, you must add coefficients in front of the chemical formulas in the equation. You cannot add or change or remove or change. We need another blank in there. The subscripts. Subscripts have to be left alone. By the way, hi Ross. I hope you had a good break. Okay, so we did a couple of practice problems and then I gave you the balancing chemical equations worksheet to do, and I hope you did all those. A couple of them were kind of tricky. Most of them were pretty easy, but a couple of them were a little icky. So the first one was H2 plus O2 yields, remember, H2O, and then you're supposed to figure out how many of each there are. So there are 2 hydrogens here and 2 oxygens and 2 hydrogens and only 1 oxygen. So it's not balanced. So we have to have a balanced equation. According to the law of conservation of mass, it has to be balanced. So we need another oxygen over here. I can't just put a subscript there. You can't mess with the subscripts. So I'll put a coefficient here into a different color to make it more obvious. So I'll put a 2 there, and now I have 4 of these, and I have 2 of these, which makes the oxygens work out, but now the hydrogens are messed up. So in order to get 4 hydrogens, I have to do that. Okay, so you just should work through the whole worksheet like that. I'll hold this up to the camera so you can see all of them. I'm not going to do each one on the board, but I'll hold it up so you can see them. Can you see that? Right there, you can see those right there. Good? Got them all? You can always pause it right here if you need to look at it. And the ones that were kind of tricky were, I think, numbers 4 and 6, maybe? 4 and 6 were kind of weird. Thank you, Oliver, because I used yours as a cheat sheet. So, yeah, I think those are the ones that you had to kind of fudge with a little bit. And remember, on numbers 3 and 7, that's AL, not AI. It's AL. And I would look like this. Okay, it's not an I, it's an L. Same thing with number 7, CL. CL, it's chlorine, CL, not CI. It's not carbon and iodine. Okay, so that's it for that. Now, the next thing you have is the lab preview, and that's on my website now. You guys, I know you're looking at my website because like 20 people emailed me today and said, I can't find the conservation of mass lab preview. I'm like, oh my gosh, you guys, give me a minute. Okay, so here it is, and it's on my website now. Sorry that I wasn't up at 7 o'clock this morning putting it on my website, but here it is now. So tomorrow, Ross and I are going to do this lab, and I have all this stuff here, and I can show you what we're going to do. You need a teaspoon baking soda, a funnel, a balloon, funnel and balloon, vinegar, small plastic bottle, There's my small plastic bottle. I'm gonna use this to pour the vinegar in because that's too big in here. And then the triple beam balance is right here. So what you're gonna do tomorrow, the procedure, measure 2 teaspoons of baking soda. So get 2 of these and use the funnel to put the baking soda into the balloon. So put this, the balloon goes on the funnel and we put the baking soda in there and then we put the baking soda down in here. And once you get the baking soda in there, it feels like one of those stress balls, one of those squishy things. That's what that feels like. Okay. And then you set that aside and you're going to put 2 teaspoons of vinegar into the bottle. So you put the vinegar in there. And then we put the balloon, it says secure the balloon over the mouth of the bottle with the balloon hanging to one side. And be sure not to rip the balloon. So we're going to put this on the top and we're going to leave this hanging to the side with the baking soda in it. And then we're going to weigh the whole thing. This is the setup. We're going to measure the mass of the whole thing. And then we'll record that. And then we're going to lift the balloon up so that the baking soda goes into the vinegar. And then we're just going to watch it, see what happens if anything. And then after 1 minute, we're going to find and record the mass of this again. That's it. There is a picture with this lab. Some people didn't put the picture on the last lab. When we did the catalyst lab with the stuff coming out of the bottle, be sure you draw a picture for this lab and be sure you write the conclusion questions down. Don't just answer them, write them down. Okay, so that's all for today, except your homework. I love how I keep saying homework. Everything is homework, Ross. Okay, so, and then as your extension for this activity, I would like you to do the chemical reactions, reactants, and products worksheet. It's on my website under worksheets, and it's front, read the front, do the back. I've done these before. And then take a picture of it and email it to me, and I can give you your score. And I think that's it for today. I will make another video for tomorrow to show you what happens during the lab, and then you can see the results. Or you can do this if you have this stuff at your house. You just need a little bottle. That's probably the hardest thing to find. A little bottle, a balloon, baking soda and vinegar, and the balance. If you could use is a kitchen. If you have a kitchen scale, a little kitchen balance. If whoever cooks in your house is picky about weights of food stuff, that would work. Okay, see you tomorrow. Love you. Bye.